Welcome to Building Accessible Web Apps, Practical Solutions for Inclusive Design. This was a talk that I gave for Tampa Devs, a developer-based community out of Tampa, Florida. We're going to get into some of the fundamentals surrounding what to look out for when crafting an accessible web application. Now, to level set, this talk should be accessible to all listening no matter what level of developer or engineer you are. Whether that is a senior developer, a junior developer, mid-level, staff engineer, you should be able to get something out of this talk. I will also note that for this recording, if you're watching or listening to this after the fact, the talk track for the original presentation that was given on June 4th, 2025 did not in fact get captured, but the video did. So I wanted this information available to all those in my network because I promised that it would be available. So what I'm doing today is re-recording the audio as best that I can. This event was sponsored by DQ Systems, the leader in web accessibility, and also by Kong, which is an API platform. Kong provided the drinks for the physical event, and I wanted to give a big thank you to the other sponsors such as Accusoft, which is a Tampa-based tech company that hosted this event in person. Without further ado, let's get into building accessible web apps, practical solutions for inclusive design. Before I get into the meat of the presentation, I did want to give a bit of an introduction to myself so that you could get to know your speaker a bit. On the right-hand side of the screen, on the top image, this shows me wearing a DQ shirt next to a giant shark, which represents the Jaws mascot. And then on the bottom, there is a beagle sitting in front of a laptop, and that is my beagle named Milo. I am a developer advocate at DQ Systems, and all that means is I bridge the gap between the developer community and marketing. So it's a bit of an engineering role, but also a community moderator, someone who produces technical content such as blogs, videos, demos, and so on and so forth. That being said, if we have any Next.js developers who are watching, I also published 2 blogs about accessibility specifically within Next.js and other React-based applications, and that's live on the DQ blog site. I could pump that into the YouTube description so that you could catch that. I studied at the University of South Florida, so I am an alumni there. That being said, I am a Tampa local. I grew up in Wesley Chapel, which is north of Tampa, about 30 minutes. And that still exists in the greater Tampa area. I am a MERN developer by trade, so that stands for MongoDB, Express.js, React.js, and Node.js. My favorite JavaScript flavor of the week is Next.js. We have an Axe community on Discord, and anyone watching this talk after the fact, you're invited, and I will be putting that link in the YouTube description as well so you could find that. Now, we had a QA in the live presentation sprinkled during some of the slides, so we had a bit of a Socratic presentation, right? So I would speak a little bit, ask a question, the audience would react to it and give an answer. So because of this, it might not translate well into the recording because I do not have an audience in the recording. So the recording will be probably a little bit shorter than the actual presentation. And so if you notice any cuts while watching the YouTube video, keep that in mind. But if you do have questions that pop up, feel free to ask them in the YouTube comments or DM me on social media or even ask them in the Discord channel that I just mentioned. So what even is digital accessibility? Bhaval Patel, in an article for Space Technologies, defines digital accessibility, also known as web accessibility, as the practice of designing and developing websites, tools, and technologies in such a way that people with disabilities can use them without any difficulties. In the tech industry, you'll also see the abbreviation ALLI. That's shorthand for accessibility. The 11 represents the numbers of letters between the A and the Y. It's also a play on the word ally, which is fitting when you think about the role developers play in building exclusive experiences. It's similar to how Kubernetes becomes K8. Now that we've defined what accessibility is, specifically web accessibility, and some of the terms you'll hear through this talk, let's talk about why this actually matters to us as developers and engineers. And to level set, again, as mentioned earlier, this isn't a legal lecture or a deep dive into compliance requirements, throwing out different jargon, but it's rather a practical, beginner-friendly, but developer-focused look at accessibility, one that's grounded in the tools and workflows that you're already using. We'll touch base on why digital accessibility matters, not just from that legal or ethical perspective, but from a technically functional one. Because here's the truth. Are better apps. Period. They're more usable, more robust, and they deliver better experiences for a greater range of users. Not just for people with disabilities. In this presentation, we'll explore exactly why that is and how you could start making it happen within your own organization and within your own projects. On this slide, the image shows a crowded airport with dozens of people sitting and waiting for their flight. It's busy, probably bustling, and everyone is occupied in their own task. Now, here's my question to you. Out of the 50 or so people in this image, how many do you think have a disability? Can you tell? Oh, wait. Most of the time, we can't tell, and that's the point. In high-traffic public spaces like this, the airport, disabilities aren't always visible. Neither should they be. The same is true in digital spaces. Think about this. What is more high traffic than a website serving millions of users? Think about Facebook, Instagram, Amazon, Publix. Now, for those who are listening out of the Tampa environment, Publix is a grocery chain in Florida, but I wanted to include that here to level common ground with the audience. If we can't tell who has a disability in person or in an image, we certainly can't online. That's why building for accessibility has to be intentional, because you don't always know who you're building for, but they're there. People with disabilities have always been here. For the image description, we have a Microsoft image, 3 different people, that defines permanent, temporary, and situational disabilities. So an example of a permanent disability would be the gentleman on the left with one arm. An example of a similar but temporary disability would be a gentleman in the middle with an arm injury. And then, lastly, a situational disability, which would be a new parent holding a baby. All 3 are prevented from using one of their arms. And on that same note, you might have a disability. In fact, 1 in 5 people, which is about 20% of the population, live with some form of disability. The CDC in 2024 even claims that the number may be as high as 1 in 4, or 70 million Americans, since they reported having disability. Disabilities are common. They've always been a part of the human experience. And having a disability, it's not unusual. It's completely normal. As you see in the image, if you weren't born with a disability, you may likely develop one or come into a situation in which you can't normally function. And if you do have a disability and it's recognized, you're not alone. You're in very good company. And that's a normal part of life. As we age, we're likely going to develop a disability, and there's nothing wrong with that. So what does accessibility even look like? On this slide, there is a road with a curb cut leading up to a sidewalk. And the curb cut has a square tactile paving that notifies the individual that there is going to be a dip. Before we step fully into our digital world, let's pause for a moment and consider the physical one, something that we probably see in our day-to-day lives. Have you ever used a curb cut on a sidewalk? That's what this image shows. It's an intentionally designed accessibility feature built into our environment. If you're blind and using a cane, you might also notice and feel the tactile paving, which is that raised textured surface that signals a change. Curb cuts were originally designed for wheelchair users, but they've ended up benefiting everyone. We roll strollers on them, grocery carts, luggage, and delivery hand trucks over them every day. That is an example of inclusive, intentional design in action. This same idea applies to the web. When we design with accessibility in mind, we often create better experiences for more people than we ever imagined. Yes, compliance can be an initial motivator, but accessibility is really about making digital experiences more usable, more flexible, and ideally more human for everyone. Now that we've seen accessibility in the physical world, let us focus on the core of the presentation, namely digital accessibility. Foundations for accessible web development. Now that we've talked about why accessibility matters, let's look at some of the core building blocks on how to make it happen on the web. What we'll consider are the foundations of accessible web development. Things that every developer on the front end should understand and apply, regardless of the framework or tech stack that they're using. What we'll cover in this section is semantic HTML, which is using the right elements for the right purpose, like button, nav, or header tags, which gives assistive technologies the structure they need to interpret your content. Next, we'll speak about why ARIA. Understanding when to use ARIA roles, states, and properties, and when not to use ARIA. Alternative text. Writing meaningful descriptions for images to ensure visual content is understandable to people who can't see it. Color contrast. Making sure text and interface elements meet minimum contrast ratios. Focus management and keyboard navigation. Ensuring users can navigate your app using just a keyboard. This includes logical tabbing order, skip links, and managing focus in components like modals or menus. First, semantic HTML. Let's start with the basics. What exactly is semantic HTML? It means using the correct HTML elements for their intended purpose, so that browsers and assistive technologies could understand the structure and meaning of your content. I want to also show an example that I came across recently on a public site. I've cropped out the tool that generated it, not to call anyone out, but to highlight what happens when accessibility isn't considered from the start, especially with this example, which is an example of an auto-generated or AI-generated code output. Just by looking at the markup, you could probably tell that something isn't right. Here are a few of the major issues. No clear heading structure. This makes it hard and difficult for screen reader users to understand the outline and hierarchy of the page. Links and buttons that lack descriptive text. It really isn't clear what each interaction does, which will create confusion and barriers. A vague page title, which is a missed opportunity to help users understand and orient what the page contains. There aren't many semantic landmarks. Elements like a nav tag, a main tag, or header tag are completely missing, which means that assistive technology can't easily break the page into a logical region. Overuse of span tags. Everything is wrapped in non-semantic elements, offering no context for navigation, interaction, or content. That being said, even if they are using non-semantic elements, they aren't going out of the way to give them proper ARIA, which we'll consider later. To the left of this image, we've listed some common examples of good structural elements. First, we have some heading elements, such as H1 to H6, and heading elements define the structure of the content. H1 is heading level 1, and H6 is the lowest level. Each of your pages should have only one heading level. Header represents the introductory content or navigational links for a section or the entire web page. Title sets the title of the web page, shown in the browser tab and used by search engines and screen readers. The nav tag defines a block of navigation links such as site menus or tables of contents. Main identifies primary content of the page, which is unique from headers, footers, and sidebars. There should also only be one main per page. The section element groups related content into a standalone block, often with its own heading, perhaps an H2. An aside tag marks content related to the main content, which is like a sidebar, a quote, or related links. And the P tag or paragraph tag defines a paragraph of text, which is used for basic blocks of readable content. So again, with a few quick reminders, you should only have one H1 on the page at any given time, and that should only represent a main heading. The heading structure should be logical and meaningful, so that if a user were to skip through just the headings, you should have a holistic view of what the document and the page should be. It should make sense and reflect the flow of the content. Don't use heading tags for styling alone. An H2 should be a subheading, not just for bigger font size. In that case, if you do want to change the font size for an element, just use CSS. Similarly, div elements should be used to divide content, not to create UI elements arbitrarily and exclusively. And this is why semantic HTML matters. It's typically the first step in the foundation of a truly accessible web experience. Without it, users who rely on assistive technologies are left in the dark, trying to make sense of a structure that was never built to include them. So, I mentioned assistive technology a bit. What is assistive technology? On the left-hand side, you could see a gentleman wearing headphones using a screen reader. And on the right-hand side, there is a woman who also has headphones, and she is also using a refreshable braille device, but she's typing with it. Before we move on, it's important to understand why semantic HTML and the other elements in this section matter so much. The reason is simple. That's how your web content communicates with their assistive technology. Assistive technologies are tools that help people with disabilities interact with digital content. Some common examples of assistive technology include screen readers, like NVDA or VoiceOver for Mac, which reads content aloud for users who are blind or have low vision. Screen magnifiers, which enlarge content on the screen for users with limited vision. Voice control software like Dragon, Naturally Speaking, which allows users to navigate and interact with content using their own voice. Switch devices, which are used by people with motor impairments to navigate interfaces using a single button or movement. And then we also have braille displays, which convert on-screen text into tactile braille characters. These tools rely heavily on clean semantic markup to make sense of a page. When you use the correct tags and structure, you're essentially writing a language that assistive technology could understand and translate into an accessible experience. If that foundation isn't initially there, then the users who rely on these tools will lose access no matter how attractive your visual design or functionality may be. Next, let's discuss why ARIA. What is why ARIA and when should you use it? Why ARIA stands for Web Accessibility Initiative, Accessible Rich Internet Applications. It's a specification from the W3C designed to make complex web interfaces, like custom components, widgets, and dynamic content, more accessible to users of assistive technologies. ARIA works by adding roles, dates, and properties to HTML elements helping describe what they are and how they behave. But here's the key point. ARIA is not a substitute for semantic HTML. If you can use a native HTML element, such as a button or navigation element, you should. These come with built-in accessibility and screen reader support, so you don't need extra ARIA markup. ARIA is typically used when you're building custom components, and they might not have a native equivalent. You may need ARIA if you want to convey dynamic changes or states that HTML can't express on its own. You might be enhancing accessibility, but you should not try to replace HTML semantics. You may also hear that the first rule of ARIA is to not use ARIA, right? So if you can write great accessible markup, you likely don't need ARIA within your application. It could actually hinder the user experience if used improperly. Now let's talk about alternative text. There are two examples on the slide, one with proper alternative text and one without any. Right now you'll see a sewing machine. On both images, it's the same exact one, and there's a good example with an image with programmatically determinable alt text, and screen readers, when they hover over the image, would say graphic, a Singer model antique sewing machine. The next is an image without programmatically determinable alt text, and the image has no discernible alt text. Most screen readers would read the file name if it can't find it. So it would sound like graphic somak2.jpg, which doesn't do much to describe the image. Alternative text is a short description added to an image using the alt attribute within HTML. You typically want to keep it concise in about 150 characters if possible. The reason for that is because when you start listening to alt text, you can't pause it and then continue from where you paused it. It reads the entire thing through. You may have already heard that you should have alt text for all images. It's essential for users who can't see images, whether they're using a screen reader, have low vision, or have images turned off for performance or data reasons. But what does good alt text do? It should communicate the purpose or content of the image in a concise yet meaningful way. It isn't just about describing what's visually there, it's about conveying what the image is there for. Here's a couple tips. If the image adds information, describe that information. Example, alt equals submit button with a checkmark icon. If the image is decorative and doesn't add value, use alt with empty quotations so that screen readers skip over it. Avoid phrases like image of, picture of, graphic of, since screen readers already know that's an image and it will declare that. Therefore, image of is redundant. Be specific but concise. You're writing for clarity rather than length. Alt text matters because it ensures that everyone, regardless of how they access your content, can understand what's on the page and why it's there. When done right, it removes barriers by giving users of assistive technology the same information presented to your sighted users. There's also an additional benefit, being that if your website's images don't load properly, the alt text should be displayed. Next, let's talk about color contrast. There are two poor examples of color contrast on the page. Left has our mission, which is a gradient of color, and the mission, the MI, is pretty difficult to read against a very bright background. And on the right-hand side, it says inspire healthy eating, but healthy is very difficult to see because it's white text on a light blue background. Color contrast is the difference in brightness between text and its background. It's critical for readability. It ensures that users can clearly see and read content, especially those with low vision are color blindness. But it's not just about having a visual disability. Strong contrast also helps people reading in challenging conditions, like bright sunlight or low quality screens. How many of you, when outside, look down on your phone and the sun is out and you could barely see what's on the screen? Color contrast could help in that case. If your text fades into the background, it's hard to read for everyone, not just users with pronounced visual impairments. The WCAG guidelines defines minimum contrast ratios for normal text, which should be at least 4.5 to 1, and large text, which is 18-point font or 14-point bold, which needs a color contrast value of 3 to 1. As in the example above, be cautious with text over images or gradients. Really, you shouldn't have text within images unless that text is properly conveyed to the user through alt text. But if there is text, the contrast has to be met throughout the whole picture, even if some part of the picture is darker than other parts. The text contrast has to be valid throughout. Good color contrast improves clarity, reduces eye strain, and supports users in all kinds of environments. Again, not just users using assistive technology. Focus management and keyboard navigation. It might be a surprise, but not everyone uses a mouse when navigating the web. Some users rely entirely on the keyboard, whether that's due to mobility impairments, screen reader usage, or personal preference. Right? It's very difficult, if not impossible, to use a mouse when you have low vision or blindness. This is why your site needs to be fully operable using just the tab, shift tab, and enter and space keys. Here are a few key areas to get right. Tab order. Focus should move through interactive elements in a logical tab order. It's typically top to bottom, left to right for English-speaking countries. If users get lost or trapped, that's an accessibility barrier. Skip links. On the slide, we have two examples of skip links, skip to content or skip to main content. These are hidden links that appear when a user starts tabbing, allowing the user to jump past repetitive content, such as headers or navigation bars. They're small, but incredibly helpful. Imagine being on a news site that has a progressive reload so you can never scroll to the bottom, right? A skip link would be helpful to skip to main content or skip to a navigation. Modals in dialogues. When a modal opens up, keyboard focus should move into the modal automatically. It should stay trapped inside while it's open and return to the triggering element, typically a button, when it closes. If focus escapes or gets lost, it could be disorienting or even make the page unusable. Focus is how users know where they are on the page and how they interact with it. If it's broken or unpredictable, the experience will fall apart. This could happen when modal pop-ups for sighted users, but what happens when a blind or low vision user can't get the proper notification when the modal pops up? The experience becomes completely unusable for that user. Good focus management ensures that keyboard users have the same access and control as everyone else. At this point, you might be wondering, how do I keep track of all of this? Right? We discussed a lot. You might be thinking, I've already built and shipped several projects, and I know some of them probably have accessibility issues I haven't tested yet, perhaps because you didn't know. Well, I've got you covered. In this next section, we're going to walk through some of the tools available to help you catch, test, and fix accessibility issues, whether you're starting a new project or revisiting an old one. Let's talk about accessibility across the development lifecycle. On this slide, we have 3 boxes It says write code with an arrow to test locally with an arrow to review pull request. When we're building software, there are a few key stages in the SDLC where accessibility issues could creep in. And each stage presents a unique opportunity to catch them. First, in the code, or within your IDE or text editor. As you write your components, issues could be introduced through, as we discussed, something like incorrect markup, missing labels, poor color contrast, or misused ARIA. This is the perfect moment to catch problems before they ever make it to the browser. Tools like linters and accessibility rules in your IDE can help in the browser during manual testing. As you interact with your app, clicking through forms, opening modals, or navigating between pages, you might uncover dynamic or visual issues that don't show up in static code. Yet, those same issues may show up when the DOM is being rendered. We should use browser-based tools to scan what's being rendered and ensure the experience works for all users, including keyboard and screen reader users. In CI, or continuous integration, think GitHub, Actions, or Jenkins after that code is being pushed. By the time your code reaches your version control or continuous integration system, it's easy to think that it's done, or perhaps it's someone else's problem, like QA. But this is where consistent automated testing is critical, especially to catch regressions or ensure that your code meets the org's accessibility standards, if they're in place. So it's often wise to integrate automated accessibility tests into your CI pipeline so that no new issues slip through unnoticed. But let's take a moment to talk about the cost of accessibility defects. Because accessibility isn't just about user experience, it's also a strategic development decision. We have a chart on the left-hand side of this slide that shows the cost in the y-axis and the stage in the x-axis. The stages are design, develop, QA, testing, and production. So there's 4 stages. Design has a cost of 1x. Develop has a cost of 5x. QA testing has a cost of 15x. And production, if those issues make it to production, cost of 30x. It's a whopping figure. When accessibility issues are found late in the process, again, during QA or during production, they're significantly more expensive and time-consuming to fix. But if we catch them early, perhaps at the design or coding stage, they're much easier and cheaper to address. In fact, according to a white paper published by IBM, the costs of discovering defects after release are significant, up to 30 times more than if you catch them in the design and architectural phase. This is what we refer to as shifting left with accessibility. This means bringing accessibility best practices into the earliest stages of your development lifecycle. It starts when we code. And that's exactly why we're beginning this particular section with tools you could use while you're coding. Because many teams don't have massive accessibility budgets, we should try to incorporate accessibility as early as possible and with the best practices we could follow. Starting with the linter. This is one of the easiest ways to bring accessibility into your workflow while you're coding. This linter is a free plugin for VS Code. It's called Accessibility Linter, which could also work in IntelliJ via JetBrains. It checks your code for accessibility issues like how ESLint checks for syntax or style problems. Think also prettier. This is an example of the Accessibility Linter as mentioned. So as you're writing, it'll flag things like missing alt text, incorrect roles, or missing labels. It'll show that to you in the Problems tab of your terminal. and you don't need to run a separate scan or open a browser. You could figure it out right in the code. Super easy to set up and download. And one cool thing, it links directly to DQ University when it flags something. So if you're unsure how to fix that particular issue, there's guidance right there. And to describe the image on this slide, there is an image with a source of corgi, and there is a class name, but no alternative text. The Linter picks that up and tells you that you need to ensure that image elements have alternative text or a role of none or presentation, but you can't just leave it without alt text. Also, one more note with this, if you're using a component library like Material UI, it has pre-built mappings for that. So if you have something like the MUI button tag, it knows that it should behave like a real button, including being keyboard accessible. You could also map your own custom components so that it tests them correctly. If you're wondering how the accessibility linter knows what to check for, or if you're open to open source, this next part is for you. The linter just mentioned, and DQ's other tooling is powered by AxeCore, which is DQ's open source accessibility testing engine. It's the same engine that powers things like DevTools browser extension and our CI integrations. It's incredibly widely used. We're talking about over 21 million weekly downloads on NPM. So this isn't some obscure library. This is the standard accessibility engine behind a lot of other accessibility testing tools across the web. It checks against WCAG, which is the Web Content Accessibility Guidelines, and includes a bunch of helpful best practices as well. On average, it could automatically detect about 57% of WCAG violations, and it flags anything it's unsure as incomplete, so you know to review it manually. This is why we could say that the linter isn't just guessing. It's powered by a robust, community-supported, and transparent set of accessibility rules. Because it's open source, you could deep dive into the repository, see exactly what's being tested, and contribute if you want. If you're a fan of open source or just want to know where it all comes from, AxeCore is the engine under the hood. Next, we have browser-based testing. This tool is also powered by AxeCore. This is one of the easiest ways to get started testing accessibility. The DevTools extension is free to download, fast and lightweight, and it runs directly within your browser. You just open up DevTools, click on the DevTools tab, and then run a scan on the current page. That's it. It'll instantly flag real accessibility issues like missing labels, low contrast, bad headings, and show you exactly where they are in the DOM. Let's see an example. The image on this slide is showing an error picked up, showing that we need to ensure elements within our role requires certain children. On the right side is the user interface of the extension, which also flagged several other issues. The DevTools extension has the ability to scan any web page and will generate a report based on the issues found. With the regular page scan, the free version of the extension will detect about 57% of common accessibility issues, again because it runs on AxeCore. Once an issue has been found, you could highlight the composite causing the failure as shown in a pink outline around the image. You could read which issue is being caused, and if more information is required, you can learn more about it by clicking on the More Information link to get a dedicated DQ University page and read more about how to fix that issue. Upgrading to the Pro version will unlock intelligent guided tests and other features powered by AI and machine learning that could boost you up from the 57% to 80% of coverage to identify accessibility issues. Next steps after committing code. For this last stage of development, after the code's been written, it's been tested in the browser and ready to go, you would likely have a testing suite or something like GitHub Actions for your CI/CD process. This is where you could plug accessibility checks into your test suite of choice. like Cypress, Playwright, Selenium with Java, WebDriver IO. And the tool here is the Axe Developer Hub. You could think of it as your accessibility control center for automated tests running at scale. Here's what it does. It watches your repository. So when someone opens a PR, it could automatically run accessibility checks. You could even set it to block pull requests if new issues are found, so accessibility doesn't get ignored. It helps you track trends over time, like which pages or teams are improving. It also makes data easy to export and share, whether that's for audits, compliance, or team visibility. On this slide is an image from the Axe Developer Hub, which shows that there are 7 serious issues, and in this particular case, its elements must meet minimum color contrast ratio thresholds, and it provides an example and a description of the issue being found. What is also being displayed here is a report from the Axe Developer Hub that automatically categorizes and filters issues based on the level of severity. All you have to do is set this up, copy and pasting a few lines of code with your API key into your existing test suite configuration file. Similar to other tools, you could start using it for free with the single API key, and if you'd want to further use it on scale within other projects, there's more that you could do with a pro membership. Further considerations. Now that we've identified common accessibility issues and tools available for remediating those issues, let's see some things to consider. Effort is required to make truly accessible apps. There's no shortcut around that. The knowledge and tools are great. They will save you time, they will catch issues earlier, and make your testing scalable. But they aren't a replacement for you as the developer. To develop something that's truly inclusive, you need skill, context, and intelligent design. That means you should take the time to understand why accessibility matters, what needs to be fixed, and how to fix it well. A great developer doesn't just run a scan and call it a day. A great developer chooses the right tools for their job and knows how to use them properly and has a plan for what they're building. When it comes to accessibility, that plan includes learning some of the different WCAG requirements so that you know what you're fixing and why you're fixing it. When it comes to accessibility, it means getting feedback from real users with disabilities so that you understand why they are unable to use your app. And you should integrate these tools like DevTools or AxeCore into your workflows so you have a process surrounding how you fix issues when they show up, because they will show up. So effort is required, but it's an effort that pays off. Not just in risk reduction, but creating experiences that work better for a larger portion of your users. Remember, accessibility is a mindset, not a checklist. And you, as the developer, are one of the most important parts of that equation. On the slide, I also have one of my favorite quotes by Benjamin Franklin. It states, "The best investment is in the tools of one's own trade." So learn how to use these tools and use them well. The tools are available for you to use so that you could create better inclusive experiences for everyone. So there's some final thoughts before the scheduled QA. Do a quick recap. We talked about why accessibility matters practically. Talked about the importance of semantic markup, alternative text, color contrast, focus management, and more. We spoke a bit about how to shift left and catch these issues earlier using tools such as Axe DevTools. And most importantly, we talked about that it's not only about the tooling, it's about the people, the process, and your commitment to building better, inclusive experiences for everyone. Thank you so much for your time and attention today. And if you have any questions, please drop them in the chat. Thank you.